we're talking about hypothesis tests today. Still chapter 23. So you actually know how to do most of this, and I'll tweak it as we go through. What's the first step to a hypothesis test? Excellent. Now, we are talking about one sample, right? So this is kind of like one proportion. So think back. We did the hypotheses for one proportion. What did that look like? P equals something, and then P is greater than or less than, right? So P was our parameter, population proportion, and we had equal to and then change in that, right? Okay. Very, very similar in this case, but we're talking about population means and not proportions. So we still have a null and alternative hypothesis, as always. But then what is the parameter for a mean? What's the symbol for the parameter for a mean? Mu. It's not a U. It's the Greek letter mu, mu, like as an M for mean. I know people tell me it looks like a U all the time, though, and it's not a U. It's an M. But it's like Greek letters, so it's supposed to be like curvy. So M equals, and then you have mu, and you have greater than or less than or not equal to or whatever. Okay? Questions about the hypothesis? Again, just like with one proportion, they should give you the population mean in the question, and then they'll give you some sort of sample data that you can use. So then you'll have a mu and you'll have an X bar. Okay? All right. Step 2 then. What's the second step of a hypothesis test? Check the conditions. Do I need to write down all the conditions? All right. It's this, all the same as the interval from yesterday. So you have independence, randomization, 10% if it makes sense, and so then you don't have success failure because you don't have proportions, so you have the nearly normal condition. Hopefully they give you data to look at or to use in a calculator. If not, then again, generally sample sizes of 30 or more are sufficient as long as there's no reason to believe that the data is going to be crazy skewed. Like if they say they're going to sample 30 CEOs, we've seen enough CEO data in this book, that might be a problem. If they're talking about the weight of 30 apples, they're probably not going to be skewed, right? So, when you check the nearly normal condition, make sure you state what you're looking at. So you just say, because the histogram provided is unimodal and symmetric, or because I created a histogram, or because I created a normal probability plot, it seems as if the data is unimodal and symmetric, so I think this condition is met. So just make sure you explain yourself. Okay. Questions about the conditions? All right. So what's the third step of a hypothesis test? Mechanics. Excellent. So there's really 3 parts to the mechanics, technically. So what's the first part of the mechanics? We won't have to pool because we don't have 2 different samples. Standard deviation or standard error. In this case, it's going to be the standard error because we're not going to have sigma, right? So we have S over the square root of n. That's why it's a standard error. We're estimating because we don't have the actual population mean. Now, again, think that we're comparing this to one proportion z-test, okay? So after we found the standard deviation for the one proportion z-test, then what did we find? We found the z. Right, in this case we're using t, not z. So let me find t. Now, on your formula sheet, again, it says test statistic equals statistic minus parameter over the standard deviation of the statistic. So with proportions, that was p hat minus p over the standard deviation, right?
Yeah.
What is the statistic for a mean? What's the symbol for the statistic, for the sample mean? Yeah, y bar or x bar. I normally use x bar. Our book uses y bar. But so it's the sample mean minus mu, our population mean, divided by that standard deviation, standard error we came up with. So very similar, right? And then after we had z for the one proportion z test, what did we do with the z? Normal CDF to find the p-value, right? Well, same thing. We need to find the p-value. I just can't use normal CDF because I'm not using a normal model. I'm using a t distribution, so you use t-CDF. So if you go to your calculator and you go to distribution menu, the first three are all normal things, normal CDF and inverse norm. Then you had inverse t, then you have t-PDF, and then you have t-CDF. T-CDF works a lot in the same way as normal CDF. It asks for boundaries. But in this case, it just asks for the degrees of freedom. The degrees of freedom for our hypothesis test are still in -1. Okay, so it's still the same thing. Any questions about that? We'll do an example in a second, but we'll do the p-value. So then what's the last step of this? The conclusion, and that is not changing at all. You say for p-value is higher or lower than some significance level, you reject or you fail to reject, and then you put that into context. Still the same thing. Now, let's see how much we were paying attention. Yesterday, what was our interval called? What was the name of it? One sample t-interval. So what is the name of this test? You guys are catching on.
On backwards breathe.
All right, so we have a one sample t-test, just like we had a one sample t-interval. These names are getting super fancy every time. I bet you can guess where we're going to go from here, like in the next chapter. Oh, look at you guys. I'm so proud. This is chapter 23 still. All right. So, any questions about the idea? We have the general idea down. It's the same concept. So I'm going to do an example. We can go from there. Here we go. All right. In 1960, census results indicated that the age at which American men first married had a mean of 23.3 years. It is widely suspected that young people today are waiting longer to get married. We want to find out if the mean age of first marriage has increased during the past 40 years. So A just says write appropriate hypotheses. So what might my hypotheses be? 23.3. Right, because it's asking to see if it's increased. Any problems with that? Part B says we plan to test our hypothesis by selecting a random sample of 40 men who married for the first time last year. Do you think the necessary assumptions for inference are satisfied? I'm not going to write them all down, but we can talk through them. So what is the first thing you might want to check? So what would you say about independence? If you were going to write this down, what would you say? We assume that the marriage age of the 40 men are independent of each other. Or you can say you assume that men are independent of each other. Whatever. Okay. What's another condition you should check? Random. And it says a random sample. So we already know that. Then what's another condition you could check? 10%. Is 40 less than 10% of all men who got married last year? Yes. Oh my gosh.
For marriage.
And then what is the last condition?
Yearly normal.
Right, so they didn't give us a graph and they didn't give us any raw data. So I can't look at something or put something in my calculator. So we got to look at our sample size. So our sample size is 40. So do you think 40 is sufficient? Is there any reason to believe that marriage age would be skewed for any reason? No, you're going to have some guys that get married younger and some guys get married older, different cultures, different things. But if you have a random sample, then you would assume that'd be representative of the population. So there's no reason to believe that it should be skewed in any particular direction, right? So I would say that the sample size is large enough so the nearly normal condition has been met. After you check the conditions, you write me a sentence. So what should that sentence be? Yay! So, conditions are met, but he's a one sample t-test. All right, we're going to skip C for now. We'll come back to C if we have time. On D, the men in our sample married at an average age of 24.2 years with a standard deviation of 5.3 years. What's the p-value for this result? So that means we need to do all the mechanics, right? So, first thing we need to do is find the standard error. So what is S? .3, the standard deviation of the sample, and then what was N? 40. So that is 5.3 divided by the square root of 40, 0.84 or 838 or whatever you want to use. Questions about that? All right, then we're going to find T, our T statistic. So we take the sample mean minus the population mean. So what's the sample mean? And then the population mean was 23.3. We're dividing that by 0.838. .07. Then I need to find the p-value. So that's the probability that T is, are we looking for the upper tail or the lower tail? Upper, because this said greater than, not just because we felt like it. So this is where we use TCDF. The second distribution TCDF, we're going from 1.07 to infinity. And what are our degrees of freedom? 39, because we had 40 people in the sample. So we get 0.146. We're going to come back to E in a second. F, what's your conclusion? What would we say? They don't give you an alpha level, so if they don't, then you can use whatever you want, and you just, at this point, compare it to some sort of significance level in your sentence. So when you say it's high, make sure you say it's higher than a reasonable significance level, or higher than alpha equals 0.05, or something that, just don't say it's high, like say it's higher than something. If they don't give you an alpha level, you can always just use 0.05, but this is 0.146. That's higher than pretty much any alpha level they're going to give you. Right, so what would the sentence sound like? Uh-huh. Quit trying to say that, because then you don't write the right thing. No, you stop. Just stop the sentence. Just make a period and start over in the next sentence. Okay, so now that you guys are goofing off. Okay, so p-value is higher than alpha equals 0.05, or it's just higher than any level of significance that would have been given. Just say it's higher than something. So we failed to reject the null hypothesis. That means there is no evidence that the mean age, make sure you say mean age, the mean age of first marriage has increased in the past 40 years. Pretty much you can take the question they're asking and you can like rewrite that with there is evidence or there's not. Questions about that? All right, we're going to talk about this p-value situation here in a second. On your last test, I gave you 3 points back on the test, not because it was like fun for me to give you 3 points back. It wasn't like random and arbitrary. Generally, lots of people missed 3 points. They missed more than that too, but they missed these same 3 points in common. They missed one multiple choice question. They were 1 point apiece on that test. Missed number 3 for whatever reason. And then they missed the last part, the last free response question. The last part of the last free response question said, here is a p-value, and I gave it to you. And it said, state a conclusion and say what the p-value means in this context. It wanted 2 different sentences. Half of you guys gave me the conclusion and stopped. Okay. Some of you guys gave me the conclusion sort of about the p-value, but not really. Some of you guys wrote me a conclusion that didn't make sense. Like it was just a normal conclusion they wanted, like just what we just talked about. It's high, it's low, we reject, we fail to reject, but some of you guys like wrote like weird things. I don't know what was going on. Some of you guys wrote a conclusion and contradicted yourself. You said we failed to reject, and then you said, so that means there's evidence that this happened. No, it does not, because you failed to reject. You guys all got all sorts of confused in the last question. I don't know what happened. I don't know because you can see them, but we're not going to go over it in class right now. All right, so we need to work on this whole p-value situation, because that's what most people miss. So I'm going to come back to this question in a second. I've got a template for what you need to say right here in purple. If you're talking about a p-value, generally you're talking about a hypothesis test. When you do a hypothesis test, you're assuming the null hypothesis is true all the way through the test until the very end. So assuming the null hypothesis is true, the probability that our sample would produce a statistic, so depending on what we're doing, proportions, means, whatever, and it needs to be in context there, okay, at least as extreme as the one we observed is about whatever that p-value is. So let me give you an example with this pizza example, then we'll go back to the marriage example. It says a researcher tests whether the mean cholesterol level among those who eat frozen pizza exceeds the value considered to indicate a health risk. She gets a p-value of 0.07. Explain in this context what 7% represents. So, assuming the null hypothesis is true, the probability that our sample would produce a mean cholesterol level at least as extreme as the one we observed is about 7%. Questions about that? This is only one way to say it. You could say there are things. But you're talking about in repeated sampling that you're going to get similar sample results that you got in this sample. That's what you're talking about. But if you need a template, this is a good one. So we talk about the question we just did with the whole marriage age thing. Assuming the null hypothesis is true. That one we had values, so you could say assuming that the population mean really is 23.3 years. You could even say that if you need to. The probability that our sample would produce a mean marriage age at least as extreme as the one we observed is about 14.5%, or 14.6, whatever we said it was. Does that make sense? That's going to keep coming up too. So just like the whole confidence thing, like 90% confidence, what does that mean? Keeps coming up in the homework. This p-value interpretation is going to keep coming up as well, because I throw it on the AP exam. Right, that last question on the test asks you to state a conclusion, which you all can do, and for the p-value in context. If you only do half of that, you can't get full credit for that part of the question, right? So, questions about p-values?